Section 7.4, we are going to be talking about percent. And to start with, we're going to look at the word itself, percent. The word percent comes from Latin, meaning per hundred, as in our cent, you know the penny, which is worth 1/100th of a dollar. That is, n percent actually means n out of 100. So my middle kids were actually talking about percents the other day and about changing fractions and decimals into percents and vice versa and so forth. And so that's actually where we're going to start this, is thinking about how we change numbers into and out of a percent form. First of all, please recognize that a percent is not a real number. It's a ratio. That's actually why it's occurring in these decimal and ratio sections, is because it's actually a ratio of 100. So when we're looking at the numbers and we're changing them, there's more than one way to do this. Sometimes it's more natural in one way or another. But the first method is to write the number as a fraction with the denominator 100. So in other words, we see the example 7.9, and we're going to figure out how I would have to change the numerator so that if I put a denominator of a 100, it's equal to 7.9. So in other words, you're just multiplying the numerator and the denominator by 100, right? So the 7.9 becomes 790, and that is now in the form over here that by definition is exactly what a percent is. So this is 790%. It's a very odd percent from the kinds of ones we see most frequently, but it's not inappropriate. It's correct. It's okay. Another method is to use a proportion. So I write 7.9 over 1 equals n over 100. And if I cross multiply, I get n equals 7.9 times 100. So again, this is another justification for how we would end up with 790%. Because this n over 100 represents n percent. And method number 3 is the one that you're probably most familiar with. Method number 3 is moving decimal points. So wherever your decimal point is located, you move the point 2 places to the right. So I'm out of space right there, really. I got lots of decimals if I wish them, and I move it 2 over. So we end up with 790% by moving a decimal point. Now you'll notice every one of these titles, and on your paper it's underneath a single title that says, a similar title that says number. It's number to percent, right? Number to percent, number to percent. It doesn't say decimal to percent. It doesn't say fraction to percent. It just says number to percent, right? And my example I used was the same on all of them, and it was a decimal. But it doesn't have to be a decimal. For example, on part B right here, we're going to take a fraction, use one of those methods still, and turn it into a percent. Just the same methods. So in part A, because you're least familiar with it, I'm going to use the first method that I did. So with method 1, what we want to do is we want to write this over the number 100. And the way that we do that is that we're thinking of this as the number 1 and multiplying by a number 100 on top and bottom. So what is 42.6 times 100? I feel like you guys want to tell me and nobody wants to talk still at the same time. Right, 4,260. Right, 42.6 times 100, 4,260. So this is 4,260%. Do you have to do it that way? No, I just want you to see that there are other options than the move the decimal way that you're familiar with, most familiar with. B is a really good example of one where you can use a proportion, okay? If you choose to use the move the decimal method on this one, it means you have a two-step problem. The first step is that you have to turn this into a decimal, and then you have to move the decimal point. But that's not the most direct way to solve the problem because nobody asked you to make this into a decimal. They simply asked you to turn it into a percent, right? So if we set this up as a proportion, n over 100, we're able to cross multiply. So I have 3n equals 800. If I divide by 3, and again, you're welcome to grab a calculator, what do you get when you try to divide what do you get when you divide 800 divided by 3? 266. Lots of sixes, right? Okay, so we'll write the 6 repeating at the end, right? Once we got past the decimal point, it was all sixes. Eventually, your calculator will round the very last 6 to a 7 because it uses rounding rules as well. But it is a repeating decimal showing up, and it's this percent. And it should make sense that this is a repeating decimal, right? It's the denominator. It's a 3. So, of course, it's going to be a repeating decimal. You bet. All right, so all of those were methods of taking a number and turning them into a percent. And now we're going to go in the opposite order. We're going to take percents, a percent, and turn it into a number. So there are 2 methods for doing this. I think that's right. Yep, 2 methods. The first one is to divide the number by 100. And then, kind of correspondingly, if you will, to method number 3 from before, we move the decimal points 2 places to the left. Okay, so we're going to do a couple examples. Directions again say to turn these percents into decimals or into number form. This is 4 1/2. Much easier to work with if we write it like this. All right? And what it really means is that I have 4.5 over 100 or divided by 100. If you grab your calculator and you actually divide 4.5 divided by 100, what do you get? 0.045. And if you think about it from the other perspective of moving decimal place values, if you move it 2 to the left, you also get 0.045. 125% is 125 per 100, right? Divided by 100. And if you divide that by 100, you get 1.25. If you think about it as I'm moving decimal points, here's my decimal point after the 5. And I move it 2 to the left to give me 1.25. All right, so all of that is like what you've done in middle school, shifting decimals around kind of stuff. From a teaching perspective, I would like for you to think about what kinds of problems, what kinds of applications actually use a percent in them. And the reality is there are 3 forms of a percent application. So if you want to use the word application, you want to use the word problem, or real world, or something like that, that's the kind of problems we're talking about. There are 3 types of application problems. The first type is called finding a percent of a number. And I'm going to give you sort of a very short question that states this type of a application without the context surrounding it. But something that ends in a question that looks something like, what is 15% of 32? So we're going to pause there, and I want to ask you, where have you seen in real life, I don't mean application problems in Texas, where have you seen real life kind of things of where you would need to find 15% of 32? Somebody said some, what?
Stores.
Sales, stores, okay. Anything else? There's another one that first, 15%, that's actually pretty common. We hear it on Geico. Is somebody thinking about Geico? 15% on car insurance. Insurance, yeah. That's one. I wasn't thinking about that one. That's true.
Tips at a restaurant.
Tips. That's the one I was thinking of. Good job. Tips at a restaurant. In fact, they often think you're stupid at this point. I don't know if you've gotten a restaurant thing at the bottom where it tells you what 15% is, 18%, 20%. I mean, I think the general population might actually need that. That's probably true. I ignore it and just do my own thing, but whatever. So, yeah, 15% is a really common tip amount. 15%, 18%, and 20% of the ones you usually see at the bottom of the tip slips. So finding 15% of 32. Another one, finding a percent one number is of another number. So it would say something like this. What percent of 47 is 12? Oops. Okay, so a little bit harder than the first question. Not in terms of computing, that's not what I mean, but in terms of thinking about where you think about it in real life. Can you think of places where you have been asked to find what percent of 47 is 12? Or they might say 12 is what percent of 47, if you switch the wording. I read a book to you maybe a week ago. Does that sound right? A week ago I read a book, or thereabouts. And it was a fractions book, but it had this kind of question in it. And it said, what fraction of the butterflies are purple? Do you remember that? If it changed the word fraction to percent, it would be this. What percentage of the butterflies are purple? Right? What percentage of your paycheck do you get to keep? What percentage of the students that you tutored last year passed their classes? What percentage of your income do you spend on gas? Hopefully at least one of those ones you've actually heard before. They're in the realm of things you should be thinking about because they're real world kind of stuff. What percentage of what portion, whatever it is something else? The third one, finding a number when a percent of that number is known. So let me write another one for this one. 13 is 45% of what number? Again, 13 and 45 are made up numbers, but can you think of scenarios again in a real world context where they'd be worded maybe like this? Have you ever heard surveys where somebody says something like, 3 out of 4 dentists recommend Crest, or something like that? It's akin to this. They're telling you 75%, 3 out of 4. Do you ever find yourself wondering, well, exactly how many dentists did they ask? Because there are occasions where I look at something and I think, that doesn't seem quite reasonable. How many people did they talk to about this? Because everybody I know would have said something else. And the number of people that they interviewed or asked or whatever in that case would give a lot of information about whether it's actually reliable or important information. We talk more about this in our section in Chapter 10 and about statistics in Chapter 10, where we look at that kind of information. How many people are we talking about when we did it? If I tell you that 100% of my students got A's, you might be like, whoa, and then I suddenly tell you, but there's only 2 people in the class, and you might be like, okay, well, you just got the 2 smart kids, right? But if I had 50 people in a class and they all got A's, that means something different, doesn't it? It does. There's more variability that's involved. So the percentage, the number out of what percent is what percent out of another number. Okay, hang on just a second. Okay, this is a good place to stop. What we're going to do next time when we jump back in with this is we're going to have some examples of these, some real-world context kind of examples, and identify which of the 3 types is actually occurring.